the source will get the electrical energy, that is from solar energy. Okay, the solar energy is a one solution for sustainable energy conversion process. And solar radiation, usually coming from sun, is highly useful in photosynthesis and is the major energy source for ecosystem. That is a well-known thing. It's a major energy source in the ecosystem. It is depleting, non-polluting and available freely. The solar energy is available freely. It is considered as a sustainable renewable energy. Only about 0.2 to 0.5 amount of energy being utilized by the solar energy. From that, only 0.2 to 0.5% of energy is utilized by plants for photosynthesis. And what other ways we use a solar energy? That is commonly used in watches, calculator and other such portable electronic devices as a power supply source. In remote villages, solar energy is the only way to meet energy requirements for lighting, irrigation by using solar pumps, domestic water supplies, and even other essential requirements are fulfilled by solar energy. It is and even the solar energy is used for cooking in solar cookers, for heating rooms to maintain a warm, and for heating water to produce a hot water. So these are the some utilization what we observed in a solar energy, by the solar energy. Okay, so these are the some. So solar energy, again, what way the solar energy conversion is observed? One way of conversion is the thermal conversion. The conversion of solar energy may be for thermal, involves solar energy into heat. Thermal conversion means the solar energy is converted into heat energy. This solar radiation is usually absorbed by a flat plate collector in the form of infrared radiation. Then other type is a photo conversion, conversion of solar energy into electrical energy. It may be converted into thermal energy or electrical energy. If the solar energy is converted into electrical energy by using photoelectric effect, in this the solar radiation is absorbed by a metal surface and photons of lights excite the electron from the metal surface. And the excited electron flows through the external circuit against the current and produces electrical energy. And the conversion device what we use to convert the solar energy to electrical energy, called it as a solar cell. Simply called it as a solar cell, or even it is called as a photovoltaic cell. Okay, it's a conversion device which converts solar energy into electrical energy. That is, the solar energy hit on the metal plate collector and the electrons get excited, and this excited electrons are flows through an external circuit and produces electric charge or electric energy. Okay, solar radiation converts the solar energy into direct current electricity. Okay, here the solar energy which has a greatest potential of acting as an alternative source of energy, because of the reason that the reserves of fossil fuels are limited and are depleted very fast. And the device what we used to convert solar energy into electrical energy, called it as a solar cell. It can be defined this way: a solar cell uh, is a semiconducting device. Okay, a solar cell is a semiconductor diode, that semiconductor, what is semiconductor, that has been carefully designed and construct, right, to efficiently absorb and convert light energy from solar cell or from the sunlight to into electrical. That is the device which is used to convert sunlight energy into electrical energy, called it as a solar cell. Solar cell is a semiconductor diode that has been carefully designed and constructed to efficiently absorb and convert light energy from the sunlight into electric energy, and even it conduct in a specific direction and generated electric current in the specific direction. Okay, so a solar energy is the energy which is a sustainable energy or alternative source of energy, because of the reason that the this reserves of fossil fuels are limited, and even it is depleted fast. So that's why we mainly use solar cells. The solar energy now, in the beginning, it utilizes only by the plant by photosynthesis. The utilization is only a maximum of 0.5%. So now the solar energy, so solar cell that can is a semiconductor diode that contains a P type and N type semiconductor. They are designed in such a way that they can absorb the light energy and the convert that light energy into a electrical energy. So that's why we consider this one is a semiconductor diode. In a photovoltaic cell, both P type and N type semiconductors are used. That's why they have that has been carefully designed and constructed to efficiently absorb and convert light energy from the sunlight into electric energy. Then, so in where we use this solar energy, what is the or the one equipment used to convert solar energy into electrical energy is a photovoltaic cell. Okay, so what is the importance of photovoltaic cell, or what are the advantage if you use a photovoltaic cell? So in photovoltaic cell, a diode present which easily converts solar energy into electrical energy. So that this solar energy is a vast in nature and is essentially infinite. Okay, that is a main advantage we observed under solar cell or a PV cell. Fuel is vast and essentially infinite. And here, if you observe, there is no emission, no combustion, or no radioactive residues for disposal. And even there is no moving part of or where here is observed. Quick installation can be integrated to a new building or the existing building structure. So this is high public acceptance and excellent safety record. Solar cell is a high public acceptance and excellent safety record. Okay, so these things you already known things. PV cell or a solar cell, it is that you utilizes a solar energy. That energy is a vast and essentially it is infinite. And there is no, we are not observing any combustion or emission or radioactive disposal. So it is an eco-friendly nature. There is no moving parts or wear tear is observed. Quick installation can be integrated into a new or existing building structure. High public acceptance and excellent safety, and even it can generate the electrical current at even at ambient temperature. Okay, so materials usually used PV cell do not undergo corrosion. Okay, and serves for a long period. What is a PV cell? That is usually made up of a semiconductor diode. Silicon chips are present, so they are not non-corroding in nature. Okay, for only current collector, what we use is a metals. All other things are a non-conducting one, or even in other words, corrosion-free metals components are used. And raw material used is a silicon in PV cell, and that is abundantly we can able to get. So then what are the disadvantages observed? That you known thing, sunlight is diffused source of light. Yeah, so they requires energy storage device. They can, this PV cell is a energy conversion device. It is a conversion device. It is not a storage device. It can only converts energy. They requires energy storage device, that is battery, which requires maintenance and replacement from time to time. That's the thing. Drawback we observed under solar cell. Okay. So here we use here we use energy. In order to store solar energy, we use a PV cell. From the PV cell, the energy created that is stored using battery. Then installation cost is very high because the silicon, that the solar grade silicon is used, that cost is too high, so that the high installation cost, but maintenance cost is less. PV cell generates only DC volt and energy can produce only in the daytime. So we can observe the energy only in the daytime, not in the night. Then what is the importance of using solar cell? The PV cells are uh, considerable attention nowadays, is one of the promising energy alternatives. Thus, important is the PV cells directly convert sunlight into electric without the aid of external power. Just if you keep the PV cells, they can able to absorb electrical energy, sorry, solar energy, and can able to convert electrical energy. Then it is stored using some storage device. Okay. Then the process and the materials of PV cell do not pollute it. They can be conveniently used even for domestic electrical appliances. They are used effectively for mining. Even PV cells are improved mainly in the remote areas. Okay, so they are effectively used in transportation process. These are the main importance of solar cells. Okay. Now, I'll consider what is the component present in the solar cell. So, the solar cell mainly consists of semiconductors. You already studied things. There are two types of semiconductor. There is a P-type semiconductor and another one is an N-type semiconductor. There are two types of semiconductor. That is a P-type. That is, I think you know, the based on the dopant used. The other one is a N-type semiconductor. P-type semiconductor and N-type semiconductor. So in the case of this N-type semiconductor, silicon is doped with an element having 5 valences electrons, such as arsenic, phosphorus are used. Okay, each atom of arsenic, when doped, replaced with the silicon atom. Of 5 valence electrons of arsenic, 4 will form a bond with the silicon atom and 1 electron left free. As a result, that free electron help for the conduction, and that is what we call it as a N-type dopant. In the case of P-type dopant, we use, instead of using arsenic or phosphorus, we use boron. Okay, a material like boron is introduced, and each atom of boron, when doped, replaces a silicon in structure. It changes into a silicon-like structure. All the 3 valence electrons of boron will form covalent bond with the neighboring silicon atom, one position left, and uh, help for the electron movement. Okay, the the semiconducting principle, you know, it is used in conversion of solar energy into electrical energy by the combustion of P and N type of semiconductors. And when you put a P and M type of semiconductor together, you will get a PN junction. Okay, N type semiconductor and P type, or in the reverse direction, if you introduce, you can get a semiconductor diode. Okay, these are highly conducting in nature in almost all temperature. Most widely used materials that you know already, it is in a solar cell, is a silicon. Okay, and silicon that is doped with either P-type semiconductor component or a N-type of component. Okay, this is about the basic things. And then what type of silicons we can able to get? There are different grades of silicons. We can observe a different grade of silicons. The one grade of silicon, what we called it as a metallurgical grade silicon. The other type of silicon called a solar grade silicon. And the one is a semiconducting grade silicon. Okay. So solar grade silicon and the pure silicon is a semiconducting grade silicon. Metallurgical silicon is a impure silicon. In between metallurgical grade silicon and the pure semiconducting silicon, we are getting, or we are observing a solar grade silicon. That means some intentional impurities are introduced to form a semiconducting, or in other words, solar grade silicon. Okay. So by using that semiconductor, it is possible to construct a solar cell. Okay. Now, how we get this silicon first? So, I'll consider the production of silicon. Later, once we can produce a silicon and that silicon is used in the manufacture of PV cells. Okay, and again the PV cell may be a module, photovoltaic module, or it may be a photovoltaic panel or a photovoltaic array. Depending upon the arrangement of these diodes, we can classify it into three categories: module, panel, and array. Okay, before I'll take how we produce a solar grade silicon. Okay, so solar grade silicon is a changed into the semiconductor grade silicon usually observed in the solar cell. There are three types: semiconducting grade silicon, solar grade silicon, metallurgical grade silicon. So here the metallurgical grade silicon is produced by submerged in an electric arc furnace. That is, silica is submerged in an electric arc furnace. The furnace consists of crucibles containing carbon and silica. It contains both carbon and silica. When the carbon and silica by using electric arc struck, a high temperature is produced and silica is reduced into elemental silicon. Silica, now SiO2, in the presence of red hot or the carbon, it converted into elemental silicon. Okay. So, with a typical purity of 98.5% is we can able to get. Okay, the metallurgical grade silicon contains intentional impurity as well as some unintentional impurities, like even transition metal ions also present in a metallurgical grade silicon. We may convert this metallurgical grade silicon into a solar grade silicon, that is, in a furnace consisting of a crucible containing carbon and silica, and an electric arc is struck in that. A high temperature is produced. As a result, silica is reduced to elemental silicon with a typical purity of 98.5%. So, silica SiO2 in the presence of carbon dissociate or reduced to elemental silica. And further, this elemental silica contains some impurities such as aluminum, calcium, magnesium, they are present. Okay, so elements less noble than the silicon such as aluminum, calcium, magnesium are oxidized and slag is formed. That is, as a silicon is when you heat that very high temperature, so aluminum introduced into the interact with the silica and forming a free silica. Again, it is a solar grade silica along with the oxides of aluminum and or oxides of calcium or oxides of magnesium. The silica is obtained now, it is 99.99% pure silica, which is again called it as a metallurgical grade, metallic grade silica. Okay, the impure silica we can convert into, or we can make it to a pure, more pure, first by introducing electric arc on the surface of carbon and silica. As a result, silica is reduced to elemental silica. And refining elements less noble than silica such as aluminum, calcium, magnesium they oxidized and slag is formed. Okay, these are then this is converted into semiconductor. So usually the semiconductor grade silicon is used for solar energy. Okay, the purification of metallic grade silicon to obtain solar grade silicon involves the following steps. Okay, so semiconductor, we usually use the semiconducting grade silicon is used in the solar cell. So here the metallurgical grade silicon is only 99% pure, and this metallurgical grade silicon is further purified to get a solar grade silicon. So how we convert the metallurgical grade silicon into a solar grade silicon? And the method, what we called it as this conversion method, we called it as a Union Carbide process. Okay, the process of conversion called it as a Union Carbide process. This process, what we called it as Union Carbide process. Here the silicon is obtained by heating. In the case first, the silicon is obtained by heating silica with carbon on calcium carbide in a crucible at high temperature. So we can get a silica 98.5%. Then it is also obtained even by a strong heating in the saline. Saline is nothing but SiH4. On strong heating at a very high temperature, we can able to get this silica. Okay, then it is further purified by the process called Union Carbide Process. Here, the metallurgical grade silicon is further processed to get a semiconducting grade silicon. Okay, what we are doing to get a metal semiconducting grade silicon? Here we'll take a metallic grade silicon which is treated with a dry HCl at 300 degrees Celsius first. Okay, the metallurgical grade silicon is treated with the dry HCl at 300 degrees Celsius. That forms trichlorosaline. A small amount of tetrachlorosalines are obtained. That means there are two components observed. Silicon in the presence of dry HCl at 300 degrees Celsius will get trichloro. There are three chlorine atom combined with this one saline. So trichlorosaline with the liberation of hydrogen. And also we'll get a small amount of tetrachlorosaline. Okay, so these are separated by means, or these are again further it is purified. The mixture is distilled to get a pure trichlorosaline. Okay, so there are two components present, then it is distilled to get a pure trichlorosaline. Okay, and what we we are doing for with the tetrachlorosaline. Again, it is possible to reduce that tetrachlorosaline into trichlorosaline. Okay, silicon tetrachloride is reduced with hydrogen at 1000 degrees Celsius in a reactor. We'll get trichlorosaline. Now, all the metallurgical grade silicon is converted into trichlorosaline. Okay, first step. You have to convert metallurgical grade silicon into solar grade silicon. So that's why we'll take metallurgical grade silicon, which is treated with a dry hydrogen chloride at 300 degrees Celsius to form trichlorosaline, and also a small amount of tetrachlorosalines are formed. And they are separated by distillations, or the mixture is distilled to get a pure trichlorosilicon. Then tetrachlorosilicon is reduced with hydrogen at 1000 degrees Celsius in a reactor. Okay, SiCl4 plus H2 giving HSiCl3 plus HCl. Okay, now further trichlorosaline is then reduced to dichlorosaline. How we are possible? It is by passed through a catalyst called fixed bed column containing quaternary ammonium exchange resin. Okay, which has a catalyst. It's a bed which contains quaternary ammonium ion exchange resin as a catalyst. Okay, that convert the trichlorosaline into dichlorosaline. Okay, trichlorosaline now gets converted into dichlorosaline by passed through a second bed of fixed bed column filled with the quaternary ammonium exchange resin. The tetrachlorosilicon, what we observed here, it can be recycled. Again, it can be reduced with hydrogen at 1000 degrees Celsius in a reactor. We can get a trichlorosaline, and that trichlorosaline is passed through fixed bed column containing quaternary ammonium ion exchange resin. So now first we'll take silicon converted into trichlorosaline. Further, trichlorosaline is converted into dichlorosaline H2SiCl2. Okay. Then the products are separated by distillation. We'll separate dichlorosaline with the tetrachlorosaline by distillation. Tetrachlorosaline is recycled to hydrogenation reactor. Then further, the dichlorosaline again it is passed through another fixed bed column filled with the same quaternary ion exchange resin. At that time, the dichlorosaline is converted into, I'm sorry, it should be to, dichlorosaline is converted into saline. That is H2SiCl2, 3 moles converted into SiH plus 2HiH SiCl3, trichlorosaline. Again, this trichlorosaline is recycled in the first bed column. We will get dichlorosaline and the tetrachlorosaline. Tetrachlorosaline is recycled, for the dichlorosaline is converted into saline. Okay, this way we can able to get a saline, SiH. 4. The above products are separated by distillation and trichlorosaline is recycled to the first bed water. Then further the saline should be converted into pure silicon, that is purified by distillation and passed into a reactor containing heated silicon seed rod. Okay, heated silicon seed rod. So saline undergo pyrolysis. It undergo very high heating and to give semiconductor grade silicon or polysilicon. This is called polysilicon. Okay, the silicon hydride, what we observed here, is purified by distillation and then it is subjected to pyrolysis, that is heating continuously on silicon seed rod mounted on a bell jar reactor to produce polysilicon or a semiconducting grade silicon. This is a pure silicon. Okay. So in this way, we can able to get a solar grade silicon, and that solar grade silicon is used to construct a solar cell. Okay, that is here I'll take solar grade silicon. First, we observe the three type grade of silicon: metallurgical grade silicon, solar grade silicon, and semiconducting grade silicon. Okay. Here, the metallurgical grade silicon is produced in submerged electric furnace. The furnace consists of crucible containing carbon and silicon, and an electric arc is struck. A high temperature produces silica is reduced to elemental silicon. Okay, that and even sometimes the silica is a less noble than the silica such as aluminium, calcium, magnesium get oxidized and slag is formed. Now, semiconductor grade silicon used in the solar energy is usually manufactured by Union Carbide Process. That is nothing but a purification of metallurgical grade silicon into a solar grade silicon. The metallurgical grade silicon, if you treat it with a dry HCl gas at 300 degrees Celsius, they form trichlorosaline. They form trichlorosaline and tetrachlorosilane. Okay, the mixture. They are separated by distillation. Okay, then tetrachlorosaline again, if we may convert into trichlorosaline reduced with hydrogen at 1000 degrees Celsius. Okay, the trichlorosaline thus obtained is passed through fixed bed column containing quaternary ammonium exchange resin. As a result, trichlorosaline is converted into dichlorosaline. And again, along with that, we can observe tetrachlorosaline, it is recycled. Then trichlorosaline is further converted into dichlorosaline by passing through a passing through a fixed bed column. Then dichlorosaline is converted into saline by passing through a fixed bed column filled with the quaternary ammonium ion exchange resin. Now, what the saline we obtain, it is subjected to pyrolysis on the silicon seed rod. That means this pure silicon are collected on the already existing silicon rod. They are deposited, and the saline usually undergoes pyrolysis to get a silicon grade, semiconducting grade silicon. This is the method we can able to get a silicon.